Morning. My name is M. Narasimha Rao, lecturer in physics. Today, I am explaining a numerical from H.C.VERMA textbook, volume 2, electric field and potential chapter, problem number 12. Two insulating small spheres are rubbed against each other and placed 1 centimeter apart. If they attract with each other with a force of 0.1 Newton, how many electrons were transferred from one sphere to the other sphere during the rubbing? Now, please listen here. Now, there are two different spheres. These spheres are rubbed together. These spheres are rubbed together. Due to the friction, electrons are transferred from one sphere to another sphere. This sphere is losing the electron. It is becoming positive charge. This sphere is gaining the electron. This sphere becomes a negative charge. Now please listen here. In this, there are two spheres. In this problem, there are two spheres. I am considering sphere A and sphere B. They are in contact, rubbed together. At the time of rubbing, due to the friction, electrons are transferred from one sphere to another sphere. This sphere is losing electrons, becoming positive charge. This sphere is gaining the electron. Now it is having more number of electrons. After gaining the electrons, it becomes a negative charge. Now, how many electrons are transferred from one sphere to another sphere? Example. Now this is the sphere A. Now this is the sphere B. Suppose one electron is transferred from one sphere to another sphere. Now this is losing one electron. It becomes a positive charge. Charge on the first sphere is equals to plus 1e. It is gaining one electron. Charge on the second sphere is equals to minus 1e. Suppose this sphere is losing 2 electrons. This sphere is gaining 2 electrons. After losing 2 electrons, the charge of this sphere becomes plus 2e. Charge of this sphere becomes minus 2e. Suppose 3 electrons are transferred from first sphere to another sphere due to the friction, due to the rubbing. Now, after losing 3 electrons, charge on the first sphere is equals to plus 3e. Charge on the second sphere, it is gaining 3 electrons. Charge on the second sphere is minus 3. Similarly, now suppose after rubbing due to the friction, it is losing n electrons. N electrons are transferred. Each electron charge is E. 2 electron charge 2E. N electron charge Ne. Charge Ne. It is losing n electrons. Its charge becomes plus Ne. It is losing n electrons. It is gaining n electrons. Its charge is minus Ne. Now, I am considering after rubbing, it is losing n electrons. It becomes a positive charge. It is gaining n electrons. The charge on the second sphere becomes a negative. Electrons are transferred from one sphere to another sphere in the integral multiple of electron charge. Quantization of charge. Electron is transferred from here to here. 1e, next time 2e, next time 3e, next time 4e. This is the quantization of charge. Now, charge on the first sphere is plus Ne, charge on the second sphere minus Ne. These two charges are separated by 1 centimeter distance. Now one is a positive charge, another one is a negative charge. In between positive and negative, there exists a force of attraction. That force of attraction is given as 0.1 Newton. They are asking how many electrons are transferred. We are having one formula, Coulomb's law in electrostatics. F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now Q1 is the charge on first sphere, Q2 is the charge on the second sphere, R is the distance between the charges. Here distance between the charges is distance between the two insulating spheres is 1 centimeter. 1 centimeter means 10 power minus 2 meter. Now F is equals to F, force of attraction between these two, that is given as 0.1 Newton. 0.1 Newton. 1 by 4 pi epsilon naught, its value 9 into 10 power 9. Charge on the first sphere plus Ne, plus Ne. Charge on the second sphere minus Ne. Now here I am taking magnitude minus Ne by R square. R means a distance. Distance is 1 centimeter. 10 power minus 2 meter. 10 power minus 2 meter. Square I am writing square. Square I am writing square. Now please listen. Here 0.1 means 10 power minus 1. 10 power minus 1 into is 10 power 2 2 ja 4. 10 power minus 4 comes to numerator. 10 power minus 4, that is equals to 9 into 10 power 9. 9 into 10 power 9 into n into n square. N represents the number of electrons transferred. N represents number of electrons. Number of electrons transferred. Number of electrons transferred from one sphere to another sphere. Now, E into E square. E square. 10 power minus 4 already came to numerator. Now, 10 power minus 1, 10 power minus 4, 10 power minus 5. Now, 9 into 10 power 9 comes to denominator. E square comes to denominator, that is equals to n square. E represents charge of electron. Charge of electron is equals to 1.6 into 10 power minus 19 coulomb. Now charge of electron, I am taking magnitude. I am taking magnitude. Now here 10 power minus 5. Is 10 power plus 9 comes to numerator 10 power minus 9 divided by 9. E means 1.6 into 10 power minus 19 coulomb. Charge of electron. Square. One more time. E square, E into E. One E is this one. Another E. 1.6 into 10 power minus 19. That is equals to n square. Now please listen here. N square is equals to 1.6 into 1.6, 2.56. 2.56 into 9. 2.56 into 9. 2.56. 2.56 into 9. 2.56 into 9 is equals to 23.04. 10 power minus 5 minus 9 minus 14 divided by 1.6 into 1.6, 2.56 into 9, 23.04. 10 power minus 19, 10 power minus 19, 10 power minus 38 comes to the numerator. 10 power minus 38, minus 19, minus 19. 10 power minus 38 comes to numerator 10 power plus 38. N square is equals to 38 minus 14, 38 minus 14, 4, 24, 10 power 24, 10 power 24, I am writing 100 into 10 power 22. 10 power 24 we are getting. 10 power 24 I am writing 10 power 22 into 100 divided by 23.04. 100 divided by 23, that is equal to 4.34. N square is equal to 4.34 into 10 power 22. N is equals to under root of 4.34 into 10 power 22. N is equals to 4.34 root 2.0, nothing but 2 into 10 power 22, 10 power 11 electrons. How many electrons are transferred from one sphere to another sphere? That is 2 into 10 power 11 electrons are transferred from one sphere to another sphere in this process.